number 9. Okay, this was 8. Ninth example we'll write here example number 9. So write the statement. It's very simple. A sphere of radius 10 centimeter. A sphere of radius 10 centimeters is heated. So the sphere is heated by applying certain temperature. Find increase in volume. Find increase in volume. Increase in volume. So comma there. If the radius has increased by radius has increased by 0.1 centimeter. 0.1 centimeter. So this is what a initial sphere. Okay, actually I should right sphere is this. This is what initial sphere. Initial, and this radius is given to be 10 centimeters. When it is heated, the new sphere is now like this. It should be bigger, and this time this radius is from its center. It is given to be 10.01 centimeters. 10.1 centimeters. So this is the we have been given the situation wherein first it was 10 centimeter was the diameter or radius, and when it is heated I get this type of the new sphere which is having this type of diameter, the radius, that is 10.1 centimeter. So what is V1 and what is V2? So we have to show V2 is more than V1 and by what percent? That is what we have to calculate here. So let's go for a very simple calculation based upon this. Now see what we are given. You can list here. Given R is equal to radius, small r is equal to 10 centimeters, and dr, change in radius, is 0.1 centimeter. These are the two quantities we have been given. Now the volume of the sphere is given by, I'll write to this end, the volume of sphere is given by, volume of the sphere is given by, this is a very simple formula, most of you know this. This is given by 4 by 3 pi as a constant into r cube. This is the formula for volume of the sphere if its radius is known. Okay, now this is what, now here I will write here this 4 by 3 phi etc is constant, so there I can write this relationship. V is a function of r, single variable, only one variable, therefore its differential dv on the left hand side is equal to 4 by 3 pi, differential of this is 2r square or 3r square. Differential of r cube is 3 times r square. So naturally this 3 and this 3 gets cancelled, and one gets dv is equal to change in volume is 4 times pi into r square. 4 times pi into r square, sorry, this dr is multiplied there on the left hand side, right hand side, so multiplied by dr. Now replace the numbers and get the dv, change in volume. So this is 4, pi is 3.14, r is going to be 10 multiplied by 10 centimeter square, so it is 10 square, and dr is simply 0.1. So multiply this, you will get this is 100 into 0.1 is 10 into 3.14 is 31.4 into 4. So if this is calculated total, it gives you, or this I can calculate this to be this is pi, so this comes to be 40 into pi, 4 into 100 into 0.1, so this is 40 into pi, and here it is centimeter cube. Okay, so write it there, centimeter cube. So dV is equal, this is given in book, so dV can be given by 40 into 3.14, so I can calculate there. 4 into 4 is 16, 4 into 1 is 4 plus 1 is 5, and 4 into 3 is again 12, and this is 12 in here, and the 12 point 125.0 is there, so this is 125.60 centimeter cube. So this much is the increase in the volume of the sphere as given by this example. Okay, so this is the final answer. So here I have seen this is the original sphere cube of diameter radius 10 centimeters. Just by increasing 0.1 centimeter, that means 1 millimeter increase in the radius of that particular sphere by heating, so V2 becomes more than V1 by a volume of 125.60 centimeter cube. So one can understand, so a large change in the volume will be observed by a very small change in the radius of the sphere by this given example. Okay, so that is our example number 9 or A9. Now next example, simple one again. Now this is related to thermodynamics. So this example number 9 or whatever, जो काही number असेल तो तुम्ही लिहू शकता. Write here the statement. For a perfect gas, for a perfect gas, we have equation, perfect gas equation, PV is equal to RT, pressure, volume, universal gas constant R, and T is the temperature, absolute temperature, where this capital R is a constant, this is a constant. Then if T changes, capital T changes, if T changes, if T changes from 400 to 402 degree Kelvin, and V changes, volume also changes, V changes from 5 meter cube to a new change in the volume is 5.05 meter cube. Find the approximate change in P. Find the approximate change in pressure, change in P. So this is the statement of the example we have been given. Now let's go. It's a PV is equal to RT, that is the relationship for this case. So first list the quantities given. What are the quantities given in the example? We have been given temperature T is given to be 400 degree Kelvin, and also we have been given the new temperature T plus delta T is equal to 402 degree Kelvin. So that shows delta T is equal to just 2 degree Kelvin. K is capital. K is capital. V was given to be 5 meter cube. V plus dV. V plus dV was 5.05 meter cube. Therefore, delta V, so dV. You can write this delta T to be this, okay, not this delta T, small delta T. Small delta T and delta V can be written as 0.05 meter cube. So this is change in volume. Okay, we have been given as the this is said to be perfect gas equation. perfect gas equation is PV is equal to R times T. Now for solving this, what we have to do, a following step we have to follow. Take natural logarithm of both sides. Natural logarithm of both sides. Take natural logarithm of both sides. Now look here, log of, we have to use this identity, log of A into B is equal to log A plus log B. Log A plus log B. I can use this here on both sides. So this is here, natural log of PV is equal to natural log of RT. You can use log to the base 10 or you can use natural log, doesn't matter, same is the thing here. So this is, next statement is, this is ln of P plus ln of V is equal to ln of R plus ln of T. Or तुम्हाला जर पाहिजे असेल तर असं पण लिहिता आलं असतं, this relationship could have been written P is equal to RT upon V. Then taking log of P is equal to log of this RT upon V. This is in numerator, this is in denominator. So I could have obtained this to be ln of P is equal to ln of R plus ln of T minus this is ln of V. असं पण करता आलं असतं. That is also valid or allowed. So you can do both way. Okay, कुठल्याही मार्गे तुम्ही करू शकता. Now we have to differentiate each. याच्यातला आता प्रत्येक टर्म आपल्याला डिफरन्शिएट करायला लागेल. And we know that differential of a constant term is 0. So here R is a constant, so log R is going to be a constant. So its differential with respect to R is going to be 0. Whereas this is variable, V is variable and P is also variable. So right here, differentiating both sides. So differentiate both sides of this equations and we will get, now I know that differential of d by dx of ln x or log x is equal to 1 upon x times dx. This is the differential of any log quantity. So I can use this formula here, getting differential of log p, it will be dp upon p. So change in pressure upon original pressure plus this will be dV upon V, change in volume upon original volume. As I said, this is constant, so it will be 0, and plus this is change in temperature, that is dt upon capital T. So now I can get dP upon capital P is equal to this term, shift it on the right hand side. So this becomes dt upon T minus dV upon V. Okay, now replace the numbers, use the numbers. We know that dt is equal to twice 2 Kelvin, T is equal to 400 degree Kelvin, dV is equal to 0.05 and V is equal to 5 meter cube. So replace the numbers, so substituting the values. Okay, so I know that this dt is equal to 2 degree Kelvin, T is equal to 400 degree Kelvin. I have written it earlier, but once again I am writing for reference. Then V is equal to 5 meter cube and dV is equal to 0.05 meter cube. So replace the numbers and get therefore dP upon P. I have to get this dP upon P and write the numbers. So it is 2 upon 400 minus 0.05 upon this is 5. So further this can be written as 0.02 upon 4. Okay, these 2 are in the denominator, that can be taken in the numerator, that's 10 raised to minus 2. so it becomes 0.02 minus 4, sorry, upon 4 minus 0.05 upon 5. So this is 20 in the denominator multiplied by 5, so it becomes 0.1, when 5 into 0.02 is 0.1, and 4 into 0.05 is minus, how much it is? Going to be 0.20. It's going to be 0.20, and 0.1 minus 0.20 is minus 0.1. Or this can be witnessed, therefore dp upon p is equal to minus, this is 0.1 upon 20, or I can write this as 1 upon pi minus 0.1 upon 200. So this 0.1 can be that means 10 raised to minus 1 in the numerator, that can be taken in the denominator, so it becomes this, and therefore final expression I can write change in pressure dp is equal to minus P there, original pressure, divided by 200. So this pressure gets decreased, thus pressure gets decreased. C D is, sorry, this spelling is wrong, decreased by a factor of minus 1 upon 200. So whatever initial pressure, it will be decreased by 200, divided by that pressure divided by 200. This much is the decrease in the pressure is lower, and that's what this change can be calculated by the simple example as given in this example number 9. Okay, so there are several other examples of the same type or similar type. We can go later on for this also in the problem solving session. Now let's go for this example 10, still simpler. Example number 10. So write the statement: how much percentage error, how much percentage error, how much percentage error is involved in a square b cube, if there is 1% error. Okay, again this is part problem of the error analysis. So 1% error in the measurement of A and B, in the measurement of A and B. Okay, म्हणजे A आणि B च्या मेजरमेंट मध्ये 1% चा फरक झाला, पॉझिटिव्ह और निगेटिव्ह whatever, then what will be the total change in the quantity A square into B square, percentage error in the measurement of A square and B square. Okay, so it's again a numerical problem. Solution. So write this one statement: let this function f of AB is equal to, form of the function is going to be A square into B cube, the given function. Now taking log of both sides, natural log, taking natural log of both sides. Now look at this, it is ln of small f is equal to ln of A square B cube. आता हे कुणाला माहित असेल, जसं मागास मी सांगितलं ln of A and B is equal to log A ln of A plus ln of B, आणि इथं जे powers असतील, this is 1 and this is 1, that's why it is 1 into, okay, 1 comes here and 1 comes here. Now this is ln of A square and B square असं असेल, this comes to be 2 into ln of A plus 2 into ln of B. So I can use this formula, in the logarithm that can be used here, but here it is cube, so therefore this becomes ln of f is equal to 2 times ln of A plus 3 times ln of b. Next 2 times ln of a plus 3 times ln of b, that is the right hand side of this equation. Now as usual we have to get differential, so differentiating both sides, differentiating both sides. So let's differentiate. Log differential of f is, log f is 1 upon f, so df upon f, df change in the quantity divided by original quantity is equal to, now this is 2 times change in a, that is dA upon a, plus 3 times this is dB upon b, change in b divided by b, change in a divided by a, and this is what this differential. Okay, now remember this is here, this dA upon a is nothing but relative error, relative or absolute error, and we know that if it is multiplied by 100 then dA upon a is equal to, this becomes a percentage error, percentage error. So here we have to multiply both sides by 100, so this is 100 into df upon f is equal to 2 here, then in the bracket 100 multiplied by dA upon a plus 3 times, again in the bracket 100 multiplied by this dB upon b. So quantity here in this bracket, quantity here in this bracket, and this quantity, all these are percentage errors, these are percentage errors, and we have been given earlier in the numerical example, त्याच्यामध्ये दिले सुरुवातीला, both a and b have percentage error equal to 1%, and therefore I can write it here, 100 times df upon f is equal to 2 times this is 1% plus 3 times this is again going to be 1%, so this is 2% per 3 plus 3% is now 5%. Okay, so right here the final statement, thus the percentage error in the measurement of f is 5%. Percentage error in the measurement of f is 5%. Okay, so there are several such other types of examples. We can go also for later on about this. When we go for this example solving session, we will go for that examples later on. Okay, there are in all 22 problems in the solved sections. We are not able to take all the problems here, doesn't matter, but we will take one very typical and simple example that is given here, example number 11. Okay, so write the statement. A balloon. Okay, now it's a different type of balloon. I'll draw the diagram later on. A balloon, spelling of balloon is B-A-L-L-O-O-N. Okay, a balloon is in the form of right circular cylinder, in the form of right circular cylinder. Balloon is in the form of right circular cylinder of radius 1.5 meters and length of that is given to be 4 meters, and is surrounded by hemispherical ends. We'll check how it comes. If the radius is increased, First we'll write the statement. If the radius is increased by 0.01 meters and length by 0.05 meters, so both are increased by, radius is increased by 0.01 meters and length is increased by 0.5 meters. Okay, 5 in the centimeters, in CGS it is that means 1 centimeter and 5 centimeters respectively, but since we are giving MK, so let's use MK system everywhere. Now find the percentage change in the volume of the balloon. Percentage change in the volume of balloon. Okay, so for that I'll draw a different diagram with another color. Now look at this. So draw this diagram correctly. We have been given a balloon of this size, so this is not coming correctly. I'm just drawing this, gone up, sorry. Yes, then this is another. I'm not needed this pen. This pen is difficult. So this begins with this. This is the length of this is, just a minute. This is the cylindrical balloon, and these are two ends of this. One end, this we have been asked this to be semi-circular. Okay, I'm not getting this correct. Look at this. This end is like this, semicircular, and this end is like this, semicircular. Okay, not this. Now this part we can make here. This is also can be made here. Sorry, this. We have been given this to be 4 meters. This to this length is given to be 4 meters. Then we have been given this to be radius, center of this. This is given to be 1.5 meters. This radius. These are the things given. And this changes by not 1 meters, and that means this changes by 1 centimeter, as I said, and this length changes by 5 centimeters. So that new balloon, whenever this type of radius and lengths are changed respectively, what will be volume of this? Okay, so again go for this pen. This is the situation given. You have to calculate the total change in the volume and percentage change in the volume of that particular balloon. Okay, so right here, radius of the cylinder. So let's go for the solution. The radius of the cylinder, it is given to be 1.5 meters. 1.5 meters. Length of cylinder is height. Length of the cylinder is going to be 4 meters. This is h. This is, I can call this to be small r. This is small h. Now when I go for volume of cylinder, capital V, it will be given by, can anyone tell me what's its volume? So pi r square into h. This is the volume of this this area. That means I have shown here is this certain pi r square is its cross section area into height is h. That gives me volume of this particular middle area, and these are two hemisphere, this plus this, okay, bottom and up. So that also gives you additional volume, and this is given by 2/3, okay, times pi r cube, plus next half, or that is also 2/3 times pi into r cube. So for that we must understand, or we must know what is the area, volume of cylinder. The expression for that should be known. Volume of the hemisphere, that also should be known. Volume of the sphere, that also should be known to you, okay. So last two quantities are exactly similar, so adding them I'll get this to be equal to pi times r square into h, plus 2 plus 2 is now 4, so it is becomes 4/3 pi r cube. Remember, adding this component and this becomes one circle, and therefore it is 4/3 pi r cube is the volume for the sphere of the radius r. So this is capital V. Okay, once we get for this, I'll get this is the formula. Now get dV, differentiating. Here we are having this functionality. The form of the function, is, we are having volume is a function of r and h. So these are the two independent variables, and this is the dependent variable. R is radius, h is height, and remaining 4/3 pi etc. It's everything is constant. So getting this differential, now there are two variables, r square and h, so we have to differentiate this. So I'll get dV is equal to, this is a product, so it is pi into 2r multiplied by h plus pi r, this again I have to just correct this, multiplied by dr, plus again differential of the same quantity pi r square h with respect to h is pi into r square will be as it is, and differential of h is simply dh. These are the two terms from the first term, and there is only one variable r there, so it comes to be 4/3 pi, differential of this is 3r square into dr. Okay, so I'll get this, and therefore dV upon V, that is a relative error or absolute error, dV upon V is equal to, so see here, pi into r, there is a pi into r, there is also pi into r, so this 3 and 3 gets cancelled, pi into r is there, so everywhere pi into r quantity is there, so that can be taken outside. Pi into r into the bracket, twice dr into h, plus r into dh, plus 4 times r into dr, and divide by, okay, total volume already we have calculated to be pi r square h plus this is 4/3 pi r cube. So everywhere you find pi r is there, pi r is here, pi r is here, everywhere. So cancelling this pi r from a numerator as well as denominator, I'll get this to be twice dr into h plus r into dh plus last time for it is 4 times r into dr divide by, now removing this pi r from this, I'll get r into h plus this is 4 by 3 r square, 4 by 3 r square. Okay, now substitute the numbers. So whatever numbers you have been given, substitute all these numbers there, and therefore it becomes dv upon v is equal to, now look at this, 2 radius is changing by 0.01 meters, so 2 into, this is into, multiplied by height is given to be 4 plus radius is 1.5 meters into dh, that is going to be 0.05 plus 4 times radius is again 1.5 into dr is 0.01. Now you can use calculator for all this calculation, or you can do on your own. Divide by r is 1.5 into 4 r into h plus 4 by 3 r is 1.5 square. And once this entire calculation, I am not doing all these calculations, you can do it at home. So this gives you 0.215 upon 9, and therefore percentage error, percentage 100 dv upon 100 multiplied by dv upon v is equal to, that is going to be 100 into 0.215 divided by 9. So this comes to be 21.5 upon 9, and that is equal to, if it is calculated, it comes to be 2.389%. Okay, thus the percentage error in the volume of not error, percentage change, bro, we are asked change, percentage change in the volume of balloon will be 2.389% of original volume. So here we have finished, actually our time is over, so we'll stop here today. In the next lecture we may go for the actual definition of this exact differential and some of the problems related to that. So we can I'm keeping or recording this as a additional problems of this total differential, so that will be another YouTube that will be made available to you later on. So this is how we have seen lot many problems, at least 8-9 different problems of this type of derivation, that is called as the total differentiation. Remember, from the examination point of view, this particular topic is very important. 1 or 2 problems from that are basically problems. There is no theoretical aspect as asked here. So most of the time these theoretical problems are asked over this total differential. That's why we have covered, at least we have taken 2 lectures for required for we have spent 2 lectures for this type of problems. Now in the next lecture onwards we'll start the exact differential and few other theoretical aspects of that. Some of the theoretical aspect, why a differential equation is called to be exact differential, what is the condition for that, and based upon that how it can be used for solving different problems in physics. So here we will stop today. Okay, thank you. So let me stop the